Hi class, so what I want to do in this video here is walk you through or help you get started on your Module 9 assignment, the case study. It's a little difficult so I'm going to provide you with an Excel file that you'll see attached in the classroom that's going to help you with this. So what you're going to want to do to get started is you're going to want to have Statcrunch loaded up too. You're just going to need it as we go through the problem, and then also you're going to want to have the Excel file that I provided you loaded up. Okay, so here's the problem. The USDA, National Agricultural Statistics Service, collects, summarizes, and distributes statistics on many elements of the agricultural industry. Okay, annual reports are published nationally and by state. So a dairy farmer provided this set of monthly, it says mild production here, but that should be milk production, in pounds for 50 of these dairy cows, okay? So, and you see this chart here. So this is the milk production in pounds of 50 cows per month. Okay, so it goes on to say is the data file may be downloaded here, and you're going to complete the following problems. Okay, so I'm also going to attach here a Excel file, and I'll walk you through and explain it here. It's a little bit differently than the one that's provided. Okay, so the first thing it says is use Statcrunch to execute the following tasks. So question 1 says use the stat tool to create a summary statistics for milk production values in the chart, and then you're going to copy and paste that chart into the problem. Okay, so what you're going to want to do is you're going to want to take your data, the milk production. You're going to want to start here in cell 3, go down to cell 52. You're going to copy it. You're going to hit Control C to copy. And then you're just going to go in and paste it, Control V, into Statcrunch. So I'm just going to put milk production here. And then what you're going to do is to get the summary statistics, you're going to click on the stat, you're going to go to summary statistics, and your data here is in a column. So you're going to click on milk production, you're going to hit compute, and you're going to see the summary statistics right there. Okay, so you're going to be able to take that and plug it right into the problem. Okay, so I'm not, just paste it in here. Next it says create a histogram to display the data in the chart and have the starting bin value as 1100 and enter a bin width that will generate between 5 and 10 classes. So you're going to go into Statcrunch here, and what you're going to do is you're going to click you're going to click graph, you're going to go to histogram, you're going to select your milk production, and you're going to start your bins at 1100 as it says. And I'm just going to select a width of 500 just to see what happens. And I'm going to hit compute. 1, 2, 3, 4, 5. Looks like I got 6 and there's none here. And you can change it. You could do a bin width of 400, whatever you want, okay? And you're going to look at this histogram here, all right? And you're going to copy and paste this into the problem. The next thing it says is based on the shape of the histogram alone, do you think it's appropriate to apply the empirical rule? So, what you just have to ask is do you think this looks normally distributed? I'll leave that up to you to decide, okay? And depending on how you select your bin width, you might get a different answer, okay? I'm going to leave that up to you. Next it says use the following results that you got in the histogram to create a frequency distribution. Okay, so what's great about Statcrunch here is if you go back and look and you hover your mouse over it, it says, you can see where it says milk production and then in parentheses 1100 to 1600. That's your class boundary, and it tells you the frequency. And then the next one goes from 1600 to 2100, and there's 16 in there. And do you see how it's on with my mouse over there? It's telling you the class boundaries, and it's giving you the frequency. So the histogram is just straight up doing this for you. So you just got to input those values into here for that. Okay, next it says determine the monthly milk production values that correspond to the following z-scores, and copy and paste this into this table here. So the good news is I decided to do this for you. I think it's a little bit challenging, so I just wanted to handle that for you. So what you can see here is you can see these are the corresponding monthly milk production. I know it says mild. There's a little bit of typo and it says mild in here. But you can see what the values are corresponding here. So the next thing that you're going to have to do is you're going to have to figure out the class boundaries for this, and you can see them. They're right up here, basically. Okay, these values here correspond to the class boundaries, and then you just have to count the values in your data set that have z-scores between these following values. And what's great here is I put a column here that has your standardized z-values. Okay, so I just did z-scores for all of these. So what you're basically going to do is you're just going to say, okay, well, how many values are between -2 and -1? Well, -2 and -1 would be these values here. So you'd go 1, 2, 3, 4, 5, 6, and that would be in here. There'd be 0 and 0 for the first two. And then what you have to do is just do that for the rest of them. Okay? Then what you have to do is, the next one says, copy and paste the chart provided, and determine the percentages that fall within 1 standard deviation in the mean, 2 standard deviations in the mean, and so on. So look, there's a total of, I believe, 50 values here. So what you're gonna need to do is you're gonna need to look at your z-scores, and you're gonna need to count, well, how many fall within 1 standard deviation of the mean on either side. So that would be anything between -1 and 1. So you have to count how many values this is, and then divide by 50. All right, and then change it to a percentage, and that will give you the percentage that fall in here. And then you have to do within 2, and then within 3 on either side. So it's a little arduous. It's not great. And then what you're going to have to see is do these match up to the empirical rule values? You know, it should be 68, 95, 99.7. Is it close to those values? Is it approximately normally distributed? You're going to have to see. Okay, then the next one says, select 2 values from the provided data on monthly milk production, one below the mean and one above the mean. Okay, so we're going to call the one below the mean A, and one above the mean is B. So if you look here, I give you the mean. So my value of A and my value of B. So I have to pick a value below 2270. So it doesn't matter what you pick. I'll just pick 1874. And then I have to pick one above the mean, so I'll just pick the first one I see above the mean, 2359. And what you're going to have to do is, I'm selecting this in my sheet, but for your report, select different values. Okay, that way everyone will get a slightly different report, and I'm not grading the same ones. I won't accept it if you select my same ones either, okay? You have to do a little bit of your own work here. Okay, so then what it says here is, let X represent a randomly selected value from the data chart. Explain why it's a discrete random variable. Well, if I'm selecting a value from 50, there's only a finite number of values. So that's basically why, because there's only 50 values to choose one. So if I select a value from it, well, you know, it just has to be a discrete random variable. So then find the probability that no more than A. So you got to find or count the number of values that are less than A. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So no more than A. No more than A, sorry. It would just be equal to 13 divided by 50. Okay, then that's pretty straightforward. And so what you'd have to do is then compute at least B between A and B and just counting, okay? And just kind of explain what you were doing there for C. All right, now getting to question 4. Let's let X represent a randomly selected number between these values that you just found. Okay. So explain why now it's a continuous random variable. Well, now it's a measurement of milk production between those two values, and there's, you know, an infinite number of possible values between these two, so it has to be continuous. Okay. So it says now assume that monthly milk production is normally distributed with the mean and standard deviation that you found, or that's in the Excel sheet. Okay. What I wanted to do now is find the probability here that it's no more than A. So in this case, you're going to have to switch to your Statcrunch calculator here. Okay. So you're going to go stat you're going to go calculators, and in this case here you can do normal. Okay, so my mean, if you look on the Excel sheet here, was 2270.5. The standard deviation was 653.18. And I want to be no more than this value, so 18 to 74. And you'd get that right there. And that's how you would tackle this assignment. So I didn't want to do all of them for you, all the probabilities, because I want you to kind of work through it here. But I've given you a way to start this. And if you have any questions or need any clarification on any of this, please let me know, and I will I'll email you back. And I know it's a hard assignment, but I'm here for you. And if you need anything, just let me know.